Let us start with the next lecture, nature of heat and work. In mechanics, the work is defined as the energy by which body is displaced through a distance d with the application of some force. So therefore, work is equal to force into displacement. Now in thermodynamics, the type of work involved is pressure volume type of work. That is, work is done when the system expands or work is done when the system contracts against the external opposing force. So here we can write pressure is equal to force per unit area. D is the distance. So if you take a container in which a gas is taken, which is fitted with a piston, and when the gas expands and there is a change in the volume, so the distance traveled by this gas, which is known as distance d. So this distance d is written over here. Now the area is equal to d square, that is length into breadth, that is d square. Volume is, as you all know, that is distance cube. Now when we say pressure volume type of work, PV type of work, that is work is equal to force into displacement or the distance. Now substitute the values of here. Force, as you know, PV type of work, P, pressure per unit area. So value of P here, it is force per unit area into volume. So force per unit area, you can write area is equal to d square. So force upon d square. Volume, it is d cube. If you cancel out this thing, you will get the equation force into displacement. Now here we are already written work is equal to force into displacement. So here force, it comes out to be force into displacement, that is equal to W. So PV type of work, that is equal to W here. Now let us explore PV type of work with chemical reaction. Like some chemical reactions you can easily use for this explanation. Suppose consider a reaction of decomposition of H2O2. H2O2, which is a liquid stored here, it decomposes as water and oxygen. In gaseous form it is evolved. If you want to balance the reaction, twice H2O2, it gives twice H2O plus oxygen. Now when this is the type of work where there is a decomposition of H2O2. Now again, if you take a container in which you have kept H2O2 here, which is the liquid, which is in liquid form. After the reaction, this is the situation before reaction. After the reaction, what happens when this H2O2, it completely decomposes. Initially it was the volume of H2O2. After decomposition, when there is an evolution of oxygen gas, this is the oxygen gas which is evolved here. This is the situation after the reaction. Now there is, you can see here, there is change in the volume. This is the expansion of the system. The system is expanded from here to here. Now the gas produced in this reaction pushes the piston upwards. This oxygen gas which is evolved here, it pushes the gas upwards so that the mass in surrounding is raised. In lifting, now mass means here you can keep the weights. You can keep some weight over here. This is lifted up and it reaches this position. In lifting the mass, the system loses the energy to the surrounding, or it performs work on the surrounding. During this work of expansion, no heat is transferred. A loss of energy by the system is equal to the work done by the system on the surrounding. And this is the PV expansion work. This is PV expansion. That is, when there is an expansion, there will be always work is done by the system on the surrounding. Work is done by the system on the surrounding. This is the case. You just remember, underline this, by the system on the surrounding, whenever it is a expansion of gas. Now for next we can take another example where there is a contraction of gas. For example, reaction between ammonia and HCl. Ammonia, it is in gaseous form. Hydrochloric acid, again you can take in gaseous form. Here there is a formation of ammonium chloride which is in solid state. So this is the situation before the reaction. Here, if you take both the reactant here, that is NH3 and HCl is taken together, and after some time when the reaction is complete, this is the initial position of the piston. It will come down to this position and there is a formation of ammonium chloride here, plus some amount of heat is evolved. So in this process, the surrounding lose energy to the system and perform work on the system. If no heat transfer occur, work is done by the surrounding is equal to gain in energy by the system. This is PV type of compression type of work. This is PV compression. This is PV compression. Now this is the initial volume. Both are in gaseous form. It is converted into a solid, plus there is some amount of heat is also evolved. When there is a compression of the gas, here work is done. Work is done on the system. Work is done on the system by the surrounding. Work is done on the system by the surrounding. So always you remember, whenever there is a work of expansion, here you can see, whenever there is a work of expansion, work is done by the system on the surrounding. Whenever it is work of compression, work is done on the system by the surrounding. So this on and by words are very, very, very important. Now, sign conventions of heat. Definitely there are heat changes during this reaction. So during this reaction, the heat changes, those are shown by some sign conventions. If minus Q, if you write minus Q, here heat is released by the system. Heat is released by the system to the, of course, to the surrounding. It is released by the system to the surrounding. If it is a negative work, if you write minus W, if you put negative sign in front of the work, you can write here work is done by the system on surrounding. Now next, if it is a plus Q, means if you put plus sign in front of heat values, heat is absorbed by the system. It is absorbed by the system from surrounding. And if it is plus W, that is work is done on the system, work is done on the system by the surrounding. So whenever it is a minus Q and minus W, this you can write work of expansion. This is work of expansion. And whenever it is plus Q and plus W, this is called as work of compression. So don't forget those two things. Here we also know that this W and Q, that is work done, and Q, both are the path function. Means the values of these two properties will depend on the path followed by the reaction. So this is about the nature of heat and work. Now the next lecture we will talk about the expression for pressure volume type of work. Thank you.